Alright.
All right, so this is the magnetic railgun project. Introduction is history of electric magnetic railgun was first known as electric gun in the 19th century by Mr. Burningfield. He stated that in an advertisement that his revolution that would cause a revolution on the battlefield, but this never came. And in 1944, the first successful railgun was made, and it launched a 10-gram projectile at the speed of 1 kilometer per second. And now in 2000, I believe it's 2014, Railgun launched a projectile at Mach 7 speed. And this is the history of the Railgun.
Alright, so why a railgun? We chose a railgun for a project because it's barely been it's barely been uh, it's barely been experimented with over the last century because it has so much potential, and although it seems like the military is the only one capable of using it for its advantage, it's also being used by civilians because there are people are developing concepts for it to be used in trains because there will be less friction and there will be more speed.
So how we thought it worked? We thought it worked like two magnets that are opposing the force, and this would launch a projectile that's in between these magnets, and that's pretty much it. How it actually worked? It worked as we thought it would. Projectiles use the magnetic field that's caused by electric current going between these rods. Would launch a projectile at high speeds between these two, and you can also use this in the military or electric trains, as he stated. Just as this, the opposing forces would speed up the train, and that's pretty much it.
Alright, so to complete this experiment or this model, you're gonna need some things that are very expensive, which I explained earlier. So you're gonna need six 400-volt capacitors, and these six capacitors are gonna be used to create two bank systems, each made up of uh, three capacitors, which are gonna be which are lined up, and then you're gonna need two metal sheets to be rested on top of it, which are gonna combine all of the bolts, and you're also gonna need some screws for for the for the wires to convert the electricity to the metal rods. You're also gonna need two metal rails, two PMA acrylic sheets, and more screws and a hot glue gun. This is basically going to be your launch pad. It's going to create a base for the projectile to be rested on, and the rods are going to act as a railway, but it needs to be balanced, which is why you need the sheets. And the hot glue gun is just to make it more stable. You're also going to need some magnet wires, which are going to be conducting the electricity. And what else would you need? You need a transformer to convert electricity into the capacitors. And you're also going to need the spring-loaded lever, which is going to launch the projectile, which can be metal balls, which will launch the metal balls into the railway to increase the velocity. That's it.
In summary, an electromagnetic railgun works as we said before. It has two rails and electric current going through a wire on one rail, going through the projectile and onto the other rail. This would create a magnetic field, which would be the Lorentz force theorem, and this would launch the projectile at high speeds out of the railgun because of the magnetic fields and the electric current going through it. And there would be no explosives involved in this. It would just be the speed of the magnetic current, the electromagnetic currents, and yeah.
And in this project, we were able to mimic the artillery used by the military by creating the railgun on a smaller scale, and by doing this, we proved that our hypothesis was correct, because there was two rods which were given a current, and then the current would then create two magnetic fields, which would create force, which was shown by what's his name, the Lorentz theorem, and then the force would like force the projectile out, and then you can't see it, but these are some results of tests which show the speed based on distance and how long it would take to reload the artillery, along with the impact and other forces that are applied.
And this is also an example of a U.S. Navy railgun used currently. There was a Wall Street Journal article written just about a few hours ago, and you can see the Navy railgun. It's used currently, yeah. And here's a homemade railgun. It's really bulky and heavy, and it also uses I'm guessing compressed gases, as you can see, just to help it a little bit more. And these are all the parts that we use.
Yeah.
There's also a picture over here, which I explained earlier, which shows two rails and the projectile. It's launched by the forces created by the electric currents and the magnetic fields. And this is an example of the magnets that attract and oppose each other. And here we have the citations of the websites that we used for this project. That will be all.